Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next test question. This is going to be an application kind of question. So we're told that the total cost in dollars of manufacturing X calculators is given by this function here, C of X is equal to 10 root X plus 1,000. And we are asked, what is the rate of change in the total cost with respect to the number of calculators X being produced when X is 1,000? So hopefully at this point, you can tell what they're asking for in the question is the rate of change at a specific X value. So they are asking for the instantaneous rate of change, right, of the cost in respect to the calculators. Now, we went through lots of different examples of instantaneous rate of change, slope of tangent in the lecture videos. I'm assuming you've watched those before we do this question, because lots of the different concepts like difference quotient, etc., I explained in the lecture video. So when we're doing this, I'm assuming that you already know all of that. If you haven't watched those, make sure you watch the lecture videos before doing this question. And in those lecture videos, if you remember, just in general, if we're trying to find the instantaneous rate of change of a function at a specific X value, which is A, we know that that's going to be what? The limit as h approaches 0 of f of a, actually, you know what? We're using c in this case. So let's say c of a plus h minus c of a all over h, like that. Right? So this here would give us an expression for the instantaneous rate of change. Now here we're given the x value we're going to be plugging in, or the a value, which is 1,000. So there's actually two different ways to do this, and I went through this in the lecture videos as well. What we can do is we could keep it general first, so not plugging in the 1,000 yet for a, just keep it general in terms of a, and then we would end up with some kind of function for the instantaneous rate of change in terms of a, and then we could plug in that a value at the end, that 1,000. Or another way we can do it is we can plug in that a value of 1,000 right away. So we could say c of 1,000 plus h minus c of 1,000 all over h, like that. And I'm actually going to do it both ways. Two reasons, just to practice, so you could get some practice with the algebra with the two different ways, to also show you how both different ways are going to give you the same answer, and just in case your teacher prefers one way or the other, or in case you prefer one way or the other, maybe you could try both ways just to practice your algebra with this kind of function in terms of finding the instantaneous rate of change and seeing if we're actually going to get the same value. So let's do it this first way, where we're going to find a general expression for the instantaneous rate of change. So we're going to plug in that a plus h into the function. So basically what we would end up with is 10 root a plus h plus 1,000, like that, minus c of a right here, which is going to be 10 root a plus 1,000, like that. And then that here is going to be all over h. And then here, if you simplify this, we want to distribute the negative inside the bracket, and then notice what's going to happen is the 1,000s would cancel out, and we would just end up with 10 root a plus h minus 10 root a, and that's going to be all over h, like that. And then from here, to solve this limit, notice that we have these square roots here in the numerator, and so what we're going to have to do to solve it is rationalize, right? So what we have to do is we have to multiply the top by the conjugate, so everything would stay the same, the end terms, except the middle term is going to change signs, right? So this is going to be plus 10 root a. Now we can't just multiply the numerator by a random expression. We have to also multiply the denominator by the same thing in order to keep this whole limit the same. It's like we're multiplying it by 1. We're just changing the format for it. Okay, so now what's going to happen is we'll have the limit as h approaches 0. Now over here, because we're multiplying it by the conjugate, it's like a difference of squares. And so we just have to multiply the ends together, right? So 10 root a plus h times 10 root a plus h, that's going to be what? 100. And then root a plus h times root a plus h is a plus h. Minus 10 times 10 is 100 as well. And then root a times root a is just a. Let's just keep it like that, 100a. All over. Now the denominator, I'm going to keep these two expressions separated, right? So this would be 10 root a plus h plus 10 root a, like that. And then let's simplify this. We're trying to get rid of this h in the denominator, right? So let's simplify this. Notice that when I distribute the 100 inside this bracket, the 100 a's will cancel out. And we'll end up with the limit as h approaches 0 of 100 h all over h, and then 10 root a plus h plus 10 root a. Here, the h's will cancel out, and now we could finally plug in that h value of 0. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Right, so what would we end up with? We would end up with 100 over 10. Okay, 0 goes for h here, so this would be root a plus 10 root a. These are like terms, so this would be 100 over 20 root a. And then 100 over 20, that simplifies to 5. So 5 over root a, that right there gives us our instantaneous rate of change, our general instantaneous rate of change for that original cost function at any x value a. And so now, because we have that general expression for the instantaneous rate of change, it's also called the derivative of the function, but you're going to be covering that more in the next chapter. Well, we want the instantaneous rate of change, remember, at that x value of 1,000 calculators, right? Or at that a value. So we're plugging in that value here for a, and so we would end up with something like this. Now if you wanted to get a more exact value, this simplifies to what? Root 100 root 10, and then, or sorry, root 100, not root 1000, and then root 10, like that. Root 100 is 10, so that would be 5 over 10 root 10, which would be 1 over 2 root 10. Like that. That's an exact value solution, or if you want to get the decimal, 0.158. And then if you wanted to get the units here, this would be what? This would be the change of the costs in dollars per calculator. Right? That would be the instantaneous rate of change of the costs at that specific point in time. When you are producing 1,000 calculators, the cost is increasing by 0.158 per calculator, right? So that right there would be the answer to this question. And now let's do it that other way, where we're going to plug in that x value of 1,000 for a right away, right? So we're not going to get that general expression first and then plug it in. We're going to just plug it in right away, and it should give us a numerical expression right away, and hopefully it gives us the same numerical expression. So let's see what happens. So this is going to be what? C of 1,000 plus h minus c of 1,000, like that, and that's going to be all over h. So if we plug everything in, so this is going to be the limit as h approaches 0 of 10 root 1,000 plus h plus 1,000 minus c of 1,000. So this would be 10 root 1,000 plus 1,000 like that, and that's going to be all over h right there. And so what is this going to simplify to? This is going to be the limit as h approaches 0. If we distribute this negative inside the bracket, the 1,000s will cancel out. So we'd end up with 10 root 1,000 plus h minus 10 root 1,000 all over h. And I'm just going to keep the root 1,000 like that. I know I can simplify it like we did before. I could also get the decimals, but for now, let's just keep it like that. Let's work it like this. And so from here, to solve this limit, we have to also rationalize. So we're going to multiply the numerator by the conjugate. So we would just change that middle sign right there, all over 10 root 1,000 plus h plus 10 root 1,000, like that. So then we'll have the limit as h approaches 0. Now, if I multiply these two, let's multiply the ends here. Okay, so let's be super careful. This times this, the 10 times 10 would be 100. And then the roots multiplied by each other would cancel out like that. Yeah, minus 100 over here, this times this, times 1,000. Like that. Root 1,000 times root 1,000 is 1,000, right? And then all over h, and then let's keep these separated. So 10 root 1,000 plus h plus 10 root 1,000, like that. Okay, so let's see what happens when I distribute the 100 inside the bracket, then 100 times this, and this cancel out, and so we'd end up with the limit as h approaches 0 of 100h all over h. This would be 10 root 1,000 plus h plus 10 root 1,000, like that. And then the h's here are going to cancel out. And then we can now plug in 0 for this remaining h here. This would go to 0, so we'd end up with 100, or sorry, 100, right? Not 1,000. 100 over 10 root 1,000 plus 10 root 1,000, like that. And let's see what this is going to simplify to, right? This is going to be 100 over 20 root 1,000, like that. Why do I keep writing 1,000 at the top? Sorry, 100 over 20 root 1,000. Sorry, lots of numbers going on here. So 100 over 20, and this would be 5 over root 1,000. And notice that that is the exact solution that we got when we did it the first way, right? When we got the general expression and then plugged in the 1,000 after. And if you remember, this basically simplifies to 1 over 2 root 10, I believe it was, right? If we simplify this root 1,000, or 0.158, right? So whichever format you put your final answer in, 0.158 dollars per calculator. That's how much the cost is increasing at that instantaneous rate of change when you're producing 1,000 calculators. Okay, so whichever way you do it, you end up getting the same solution. Yeah, and that's it for the question. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.